Know this. Um, Always, and people keep asking like after class, like what's on maybe a quiz tomorrow. Anything we've covered, guys. Okay, as we move on, that's the purpose of quizzes, so that you're always preparing. Okay, so if I tell you what to prepare for, then you're not maybe preparing for other things. Does that kind of make sense, or really approaching the course in regards to all the material being important to us. Okay, so anything we've covered lately is usually what we're going to do on quizzes, but I could go back to anything we've done. All right, because of how much that stuff gets used over and over and over and over again throughout the course. Okay, we usually won't put like in regards to using this material, this content, so domains and ranges, there won't be a big gap between the next time we use it. Okay, it'll be very continuous throughout the course. So this first one asks us to find the domain and range, and guys, I know it's hard, maybe with a piece of paper, to do what I'm doing. Okay, because I'm going to draw our horizontal lines and vertical lines in here. Okay, but there's nothing saying that you can't take a piece of paper. Okay, fold it over a couple times, get a straight edge, or take a ruler, take the edge of your calculator, and use that as a visual guide for you to come up with the domain and range. Now, eventually, hopefully, that's not something you need, but initially, maybe that's something we kind of address here. All right, so this vertical line, what's the first x value that's going to be incorporated? -6, right? Now, do I use -6? No, but I have to incorporate it so that because I can't write -5.9 an infinite number of times with that 9, right? So I've got to use -6, and I put a parenthesis on there to tell me I'm not really using -6. That's not an x value when I write all my ordered pairs out, but the value directly to the right of it is. Okay, and what would be the last x value that I come across? 3. Okay. Now I messed up on when I was writing my domain, but that's on my key. That should be, we're going off the bracket here. Okay, so -6 to 3 with a bracket around 3. That's my domain. Now my range is a very similar process, but my range is now moving a horizontal line upwards. Okay, so moving this up, first y value that I would encounter would be -3. And I keep going up, and a lot of people got here to 1 and say, I got to kick out 1 because he put an open dot right here. But remember what's going on. When we write these two things, when we write these domains and ranges, we are writing essentially the structure for every infinite ordered pair that we come across. And we're saying when I write my range, inside there is every single y value that would come in an ordered pair. Does that make sense? For this curve. Will there be an ordered pair with a y value of 1 in this curve? Absolutely. There's going to be 2 of them, right? Okay. They're going to be here and here, right? Okay, but what we're saying is -6 will not be paired with 1. That's all that open dot is saying. Okay? But these will have 1, so I need to have 1 included in my range. What's the last y value I come across? 3. Okay? So I need to go from -3 to 3, including both those. All right, so we'll do the same structure over here. All right, so as I move this thing through, first value I encounter, -7, right? Okay? And I keep going, and I get to -5. And there's an issue at -5, correct? When I get to -5, my blue line should be passing through a hole. Okay? So if we were to... Let me see if I can make you kind of understand what's going on with this visually real quick. Because I don't think some of us are fully grasping it. All right, so the x value that I'm going to have an issue with is here at 3, right? I'm going to divide by 3 here in this one. So let me put a line. Actually, what's going to happen when I zoom in far enough on this, guys, okay? When I zoom in far enough on this, there's going to be a gap where this line or segment stops right there, and we skip over, and then it starts again. Does that kind of make sense to everybody? Okay. That's why we've got to kick those out. Okay. There is a gap. Now, I got to zoom in infinitely further than what I currently am. Okay. But eventually, we will find out that there is that gap right there. There's a hole there that is existing. Okay. I'll see if I can put together kind of a GeoGebra applet that shows this concept, and you can see that gap. But that's what the open dot is showing. Okay, is that this left-hand side, we're getting as close to -5 as possible from the left-hand side, and we're getting as close to it from the right as possible. But we never get to it from both directions or either direction. Okay, so we got to kick out that -5. Remember, this is the notation that we use to kick out numbers. Okay, -5 union, then pick up with -5. So this means right here that we get to -5.000000001, and this says we get to -4.999999999. Does that make sense? But -5 is never an aspect of this domain. I then get up to -1, and -1 also needs to get kicked out, correct? So again, you see that notation there saying -1 from the left-hand side, you get up to -1.000, infinite zero, slap a 1 on the end. And on the right-hand side, you get to -0.99999999999 forever. But you never get to a -1 from either direction, right? So kick that out. That's what that means. Okay? Now, as I move that blue bar through, what's the last x value that I encounter? A lot of people put 4. Okay, but that arrow means we keep going on to infinity, right? Okay. So that's the interval we're looking at. Now, when I do the y values, do the range, I get here, okay, and a lot of people kick 3 out or -3 out because there's an open dot there, right? But isn't every one of these ordered pairs right here going to have a y value of -3? So -3 is going to be, when I list all my infinite order pairs, -3 will show up in some of those. Okay, so I need to include it. Now what happens is a lot of people started moving this thing up and said, okay, I'm intersecting here. Where my cursor is, I'm always intersecting, right? Intersecting twice now, that's good. But I get here and I'm not intersecting, correct? So they put 4 and put a parenthesis around it. What's that thing mean? It's going off in that direction forever, right? Okay, we put arrows on something, it means that it's going to show that behavior for its entirety, all the way through, whatever x value. So we're going through infinite x values. So if I keep showing that behavior, can you imagine that when we get out to like 100 or 200 or 300, or maybe it takes us out to 100 billion, at some point, we will have a y value of 4, right? Does that make sense? Okay, and we can kind of interpolate that we would have a y value of anything that we would want that is greater than -3. Okay, that's why we got to go from -3 to infinity on that interval. Is that okay? I know, like, we are maybe used to when we graph things on our own because we get lazy. We don't put arrows all the time. And when we're lazy graphing on our own like that, then when we interpret or read somebody else's graph that does have arrows, we just inherently avoid them or don't think about them. Does that make sense? Or we neglect them, not on purpose, but it's just because we don't pay a whole lot of attention to them when we draw them ourselves. We forget that there is meaning in them. Okay, and especially for our domains and ranges, they're extremely important. This one here wasn't really the domain that we struggle with too bad here. But when I start going through here, -7 is going to be the first value I come across, right? and I keep going, no issues yet, and I get to -5. Does -5 need to be kicked out? No. Okay? It's just not going to have a y value that's stuck with 1, right? It's going to have a y value that's stuck with 2 because that's where that closed dot is. A lot of people tried doing this. They said, we're going to go from -7 to -5. We're going to kick out -5. But we're going to union, and we're going to bring -5 back in. Okay? You can't do that. All right? That's never been something we've talked about, discussed. That's incorrect notation. If you're going to union by kicking out one value, you can't kick it out and then bring it back in. Is that all right with everybody? Because when you have somebody read this, you don't want them to have to do that logical thinking. Well, they kicked it out here, oh, but they put it back in, so now I got to remember that it's in there. Does that make sense? When I write it this way, there is no issue of whether -5 is in or out. I know it's got to be in. Does that make sense? Okay. So -5 is in. I get up to -2. -2 needs to be out. So we union, or sorry, per parenthesis, and then we union with the rest of this stuff. There are no x values in here. Okay, so we're not going to incorporate those. The next x value that is important to me is 1. And I pass through everything from 1 to 5, but I don't include 5. I got to have a parenthesis there. Now when we do our range, -1 is the first one you encounter, right? The only issue we come across is right here, maybe. Okay, but will I have a y value of 1? Yeah, because that's a closed dot and that's closed dot, right? Even though that one's open, we pass through there. That just means this little segment doesn't get up to that line. That's fine. This segment does, and so does this one. Okay? Now, some people were just kind of maybe looking at, I apologize for that, looking at just this kind of portion of the graph when they're answering the rest of this. And they're saying, oh, we skipped some values there, right? We skipped some y values. But are those y values picked up over here? Yeah. Okay, so you can't kick out y values from 1 to 2 because they are being recorded over here. Okay, so right now, I've gone from -1. All that stuff's good, we're okay. All that stuff's good, we're okay. I get up here to 4, and 4 is the only one I need to kick out, right? So -1, inclusive, 4, exclusive. And that's our range for that. Okay. You can see here I kind of did the work. For some reason I didn't divide both sides by 2 here to show that work, but I did record it down here. What I needed you guys to do here, and some, for the most part, I'd say probably 95% of us got this one right. But some people did this. They said, oh, it's a less than, so we went straight to this. Is that allowable? Now, remember, we're in the between statement. This number here on the left has to be the smallest number, right? This one has to be the greatest. Now, don't make that think that you can just then flip-flop and get that negative and that positive. Well, you can't do that. In order to apply our absolute value rules correctly, it makes sense to rewrite the first initial problem that way. And now you see it be an or statement, right? And that gives us those two inequalities. We can solve those and then record those inequalities in interval notation. So x greater than 11 would be this. X is less than equal to -5 would be that. Okay? And this next one, for a lot of people, okay? Only a handful out of, I don't know, 35 of us maybe, got this correct because we're doing that, you know, and I've tried to ask you to fight this, but every time you come to a problem, think, okay? Arithmetic, order of operations, add, subtract, multiply, divide, all that stuff is math, guys. But thinking about what allows you to do those and why you can do those and when you can do those things is maybe a higher level of math, okay? And maybe a more important aspect of math, right? Because I can give you guys any incorrect equation or inequality or whatever that represents some situation. You can all solve it and get the incorrect answer because the formula was incorrect. Does that make sense? Or the logic that we used to solve it was incorrect. Okay? This one, a lot of you just kind of went Well, I just got my 9, so I get 3x plus 3 absolute value greater than -5. Okay, that's an OR statement. So then we said 3x plus 3 is less than 5 as well. And we solve those, and you got some weird interval, kind of like 8 or something like that. That is incorrect logic. Okay, because once I do my first operation here, absolute value of 3x plus 3 is greater than -5. When is absolute value greater than a negative number? All the time. Off the definition of what we mean for absolute value, that's a situation that always occurs. So we have to make sure that we understand it. Okay? We get in the habit of saying, okay, I did one problem, here's another one just like it. Don't even think about what's going on. Don't even think about what each line is saying to me. And I just go through the arithmetic. Okay? And I get solutions. I think those solutions are answers. That's an issue, okay? If you did do that, okay, I understand that. I understand that can happen. But especially when you get interval solutions. Something to think about, guys, when you're doing these. I think, let me see real quick. I think I got somebody's back here that had this. We had like, I think if you do this right, no, this person did it wrong. What happens is you get some intervals here when you solve this. Okay, so let's say that I get, and I'm not sure what they look like, okay, but let's say that I get that interval and that interval for solutions, okay? A good idea is to say, okay, let's choose the next value that is in this interval, I don't care what it is, and plug it in here and see if I get a true statement. Does that make sense? Then come over here and say, okay, plug this x value in that comes in this interval, don't care what it is, make sure I get a true statement. Does that make sense? Okay? And a lot of people are done then. But I would go even a little bit further. I would say pick an x value that is in this interval. And what should I get in that interval when I plug it back in? I should get a false statement, right? But in this case, because those should actually be answers, we would get a true statement. Does that make sense, everybody? And that logic tells you I've messed up. I've done something wrong. Okay? And that shouldn't be something that's extremely difficult. You can do that with the calculator real quick, checking those values. You can type that into like Y1, and then go to your table and evaluate at those intervals. And again, you can also, I guess, checking that thing. Could you graph that? If you take your TIA3 or Desmos or whatever and graph those two things, you'll see that the absolute value kind of B that we talk about with linear absolute value will never intersect at a height of 4. It will never intersect at a height of 4. Oh, I'm sorry. It will always. I'm thinking equality. It will always be above the line y equals 4. Does that make sense? Let me show it to you. Just, I misspoke there. All right, so we have the, what was it, absolute value. Is it 3x plus 3? And then I had plus what? Plus 9. Okay, so that graph, let me zoom out a little bit, is that thing right there. Okay, and then I've got 4. Y equals 4. That line right there. And the question is, when is the red one greater than the black one? The answer always, right? They never intersect. So they're never equal. So they're always, in this case, the red one's always above. So that's how we would approach that question. Later this week.